Hi, this is Tom Roth, Automation Specialist at Revere Electric. I'm here to talk to you today about Rockwell Automation's line of Ethernet encoders, specifically the 842E-CM SIP motion encoder.
So why use an Ethernet encoder? One reason is the ease of setup using the Rockwell Automation add-on profiles or AOPs that come with Studio 5000. These AOPs help set up the properties of the encoder and give you tags that mean something for you to use in your project. No interface cards that are just for an encoder, just real data for you to use. Ethernet data is read in as tags into the project. Scaling can be done in the module properties. It gives you position over Ethernet by default, but you can also get velocity over Ethernet if selected on the General tab under the module definition. The 842E-CM SIP motion encoder requires a motion processor, like a 1769L36ERM, where the M stands for motion, and scaling is done in the axis properties. It gives us position over Ethernet. We can also get velocity if selected in the cyclic parameters in the axis properties. It is used for a feedback-only axis for dual loop motion, and it updates with the course update rate of the motion group, which has to be set to 4 milliseconds minimum. The encoders are available with single and multi-turn resolution. Both are absolute encoders, but let's talk about these differences. The S, single turn, gives us 18 bits for each revolution of the encoder. If it rotates past one turn, the data resets and starts counting again. As long as the power is maintained to the controller, we will be able to track where the encoder is relative to the application. If the power is shut off, we may not have absolute data because it cannot track if the shaft turns when the power is off. The M is multi-turn 18-bit per revolution plus 4096 turns for 30 bits of total resolution. This allows the controller to track if the encoder shaft has moved more than one turn. You can think of it like a clock. The minute hand will track how many minutes have passed, and if you're always watching it, you can get a total number of minutes passed. If you walk away and the clock moved past 12, then you cannot be sure how many minutes have passed. But with the hour hand, you can track 12 consecutive hours of time even without watching it. The 842E-CM is designed for motion control applications and supports the standard motion instructions in Studio 5000. Possible uses include rotary tables, material handling, pick and place, or load feedback on any axis with gearboxes or belt drives. There is a dual-port Ethernet connection on the rear of the encoder. The Ethernet network can be configured as a star, linear, device level ring, DLR, but the network switch needs to be capable of DLR. Now let's go to Studio. First we have to add our encoder, create new module, go to 842E-CM-M for multi-turn encoder, create. Now we have to give it a name and an IP address. Click OK. Close this dialog. Next, go back into the encoder, and we're going to create an axis. New axis. Call it axis 1 underscore FB for feedback, and we're going to create it. Click OK. Now we're going to check for time synchronization for SIP sync, SIP motion. Make sure that is enabled under the processor, under date and time. Click OK. We move our axis into the motion group. We check our motion group to make sure that it's set to 4 milliseconds minimum. And we go back into our axis. Notice it's feedback only axis. Now we go to scaling, change our units to degrees, and go to 360 degrees for one revolution of the encoder. Now, when we go back and we're going to download, make sure it's in run mode when we finish. Now that it's downloaded, we're going to go back into the axis, We're going to go to Status. In the Access Properties, you'll see it's a very large number, so we're going to 0 the encoder. We can do this with the Motion Direct command. Motion Redefine Position, MRP. Set that to 0 and execute it. This can also be added to code. Now we're going to rotate our encoder 1 revolution approximately. You can see the velocity is going up. We can also look at this in our controller tags. We're going to look for actual position and velocity. We'll rotate the encoder 1 more revolution. You see the velocity go up as we get to approximately 720 degrees. For more information, please visit revereelectric.com or rockwellautomation.com. Thank you.